Today we will be looking at proportional relationships, and they're also referred to as a direct variation. Number one, what are the characteristics of a proportional relationship? We will attempt to answer that question. And number two, what is the constant of proportionality? Proportional relationships. Also called a direct variation. Well, they have two main characteristics. Number one, they are linear. And you see that linear has this root word line. Linear means can be modeled with a line. That is, when we graph it, the points will line up such that we can draw one straight line through all the points. Number two, it will contain the point 0, 0. Let's investigate an example. Proportional relationships, they are something that we see all over the place. In your experience in math, you've dealt with many proportional relationships. We typically think of cross multiplying when we think of a proportional relationship. Here would be an example. Grandma bakes 1 dozen cookies per hour. At this rate, how many cookies could Grandma bake in 3 hours? Well, hopefully that you see you could simply multiply by 3. Or you might consider setting up a proportion. But right now we want to see that this situation is a proportional relationship by examining these two characteristics. So I'm going to draw a graph that models Grandma baking these cookies. On the x-axis in this case, I'm going to put our time measured in hours. And on the y-axis, I'm going to put cookies. Okay, so we want to get up to 3 hours. I'll try to make my intervals the same length. That's going to be key to getting the linear situation. So 1 hour, 2 hours, 3 hours. The y-axis, I will use my lines to help here. 1 dozen is equal to 12. Hopefully we're aware of that. So 12 cookies, 24 cookies, and 36 cookies. Alright. 1 hour is a dozen cookies. That would be this point right here. 1 hour corresponds with a dozen cookies. Well, 2 hours then would be 24 cookies. And 3 hours would be 36 cookies. As you can see, these points are indeed falling in a straight line. So using a straight edge, I will draw a line through these points. Well, as you note, the line crosses the origin down here. The origin, this point, is 0, 0, where this first 0, the x, references time, and the second 0, the y, references cookies. Clearly, in 0 hours, Grandma will have baked 0 cookies. This relationship is proportional. It is linear. You can draw a straight line through it, and it contains the point 0, 0. All right. Next, we need to consider the constant of proportionality. Constant of proportionality. We use the letter K to signify the constant of proportionality. Alright, K is defined by y divided by x. And let's look at that with regards to our grandma cookie scenario here. Alright, so again, our x variable and our y variable. Well, the x variable is time, measured in hours, and our y variable is cookies. So we know in 1 hour, Grandma was baking 12 cookies, 2 hours, 24, 3 hours, 36, so forth and so on. Well, let's examine what this value K is going to be. K is simply y divided by x. K is y divided by x. So let's look at that division in each one. The first y-x pairing, or x-y pairing, is 1/12. So y divided by x is 12 divided by 1. 12 divide 1. Well, 12 divided by 1 is clearly 12. Our second pairing would be 24 divided 2. Again, y divided by x. Well, 24 divided by 2 is also 12. The last one we have in our table would be 36 divided by 3. 36 divided by 3 is also 12. So what we see here is when we divide each one of these y over x's, we get 12 each time. When you have that situation where each y divided by each x is equal to 12, then that will be another check for a proportional relationship. So, lastly, we can write an equation that will model this direct variation or proportional relationship. Equation for direct variation. This simply requires a little algebraic manipulation. I'm going to solve for y in our previous equation. To do so, I'd multiply by x on both sides. So I can rewrite this statement as y equals k over x. Again, x is our time, how long Grandma was baking, and y is her cookies output, cookies baked. Okay. This k is what we just calculated. It is her rate. we also call it slope. So I can change this equation to y equals, instead of k, what we calculated k to be, which is 12, and x. So I can take any x, any time, and substitute it in place of x here, and it would tell me how many cookies Grandma could bake in that length of time. This 12 is Grandma's baking rate. It is her cookies baked per hour. It is also called her constant of proportionality.